In this video, I will continue to explain the connection between IoT ESP32 and single point view. Exercise 4 and 5. Edits. An automatic ranging model and temperature and humidity sensor compared to exercise 1 to 3. The video is divided into 5 parts, namely mean connector, measures list, code analysis, single point view connection, and final effect demonstration. Okay, this is the first mean connector. The mean connector is to connect the ESP32 and single point view and conduct 2 exercises. The exercise 4 is to control the LED light on and off and added an automatic ranging model. Exercise 5 adds temperature and humidity sensor based on exercise 5. The video emphasis is placed at the end of the PPT. Okay, this is the part 2 measures list. The measure used are 1 ESP32 and 9 2-point wheels. For one breadboard, one resistance, and one LED light. Other is automatic ranging module and temperature and humidity sensor. And then is Arduino IDE and the single point view. This is the code for exercise 4. This code implements an auto-synthetic ranging system besides on ESP32 and a single point view platform. The main function is measure the distance through the HC SR04 auto-translate single point view model and the upload the data to the cloud. Will supporting remote control of the LED lights connected to GPIO14. The code first configures the Wi-Fi connection and the IoT platform authentication information. Initialize the hardware in setup and loadings the cloud control interface, where the scene automatic reverse handles distance measurements, and the scene LED resource provides room on-off control of the LED. In the main loop, scene handle is used to maintain the cloud connection and handle connection transaction at 100 ms intervals. The overall function of a typical IoT terminal device is realized with single data connection and remote control completes. This is the video shows the final results of the exercise 4. This is the code used. Then a connection with the single point U is shown. Photo 1 can control the LED light. Okay. Then the model 2 can measure the distance. Where I use a cup as an experiment. Okay. Since exercise 5 includes exercise 4, so I will focus on the explanation, the code of exercise 5. This is the code for exercise 5. It uploads on exercise 4 by adding a temperature and humidity sensor. This is the flows for simultaneous distance measurement, temperature, and humidity control as well as LED light control. Finally, visualization is included. I will explain each section below. Okay, this is the part 1 header field and the library introduction. This section introduces the serverless library fields to lay the foundation for the subsequently function implementation. The single ESP32 library is used to connect to the IoT platform, and the DHT library is used to drive the temperature and humidity sensor. These libraries provide slotted APIs to simplify the development process. And this is the part 2 device configuration micro definition. Comfortably managed device creates the network parameters through micro definitions, making maintenance and modification easier. Parameters such as username, authentication information for connect to single point view. View SSID and password are used for Wi-Fi connections. As centralized defined information improves code readability and seriously and security. This is the part 3 hardware pin definition. The GPIO pins for each sensor connection are clearly defined to functionative hardware built-in and maintenance. The pin and in-pin correspond the single and equal pins of the obstruction model respectively, and the DHT pin section flags the data link of the temperature and humidity sensor. This is the part 4 object. The key function or object instance are created. The scene object is the core instance for connecting to single point view, and the DHT object is responsible for connecting with the temperature and humidity sensor. The international parameters of those projects correspond to the macro-specified previously. And this is the part for set file initialization function. Complex system initialization, including serial port cell type, pin model settings, network connection, and the code several loading. This function is executed only once when the device is proved on the paper for secondary operations. This is the part 6 data crossing function. This contains is specific sensor data connection and processing logic. Sonic ranging use place equal most and temperature and humidity readings use the DHT library API. After processing, the data is returned to the cloud via a Python object. This is the part 7, mean loop. The system's mean loop runs continually, responsible for maintaining the cloud connection and hiding various events. Seeing handles is the core method of the single point view, and needs to be physical gradually to keep the connection active. This is the part 4. Helper functions, connecting the utility functions such as unit conversion microseconds to connection co-timers converts the time value measured by ultrasound into centimeter distance in Catherine speak specific calculation logic. This is a single point view connection. Inference of single point view after cloming exercise 5. Four switches will appear. They means temperature, humidity, distance, and control the LED light. And a visual display is provided. This video shows the final result. Okay, this is the code for exercise 5, and this is the single point view connection page for exercise 5. First, we will test humidity. Placing my hand over the temperature and humidity sensor will change the humidity. Okay, next I will switch the LED on and off the LED. Okay, and then I display the temperature. Placing my hand over the temperature sensor will change the temperature. Currently, I will measure the distance using a mouse as I explained to demonstrate different distance measurements. Okay then, and the video closes with a visualization page. Okay, my explanation is over. Thank you for everyone.